So just to do some examples with quaternion multiplication, you guys are probably familiar with complex numbers. I squared is -1. When it comes to quaternions, these are going to be numbers with coefficients. It's going to have a real number together with a number, a multiple of I, a multiple of j, and a multiple of k, where these are going to be real number multiples of I, j, and k. And I squared is going to be the same as j squared, is going to be the same as k squared, which is going to be -1. But I, j, and k are not going to be the same. They're not all going to stand for the square root of -1. This is a different system, a different structure. Here, I, j is k, and j, k is I, and ki is j. So what we can do is we can sort of do this little thing, draw a little picture here. If you take I times j, you get to k. If you take j times k, you get to I, and if you take k times I, you get to j. However, if you go against this wheel, so you go against the arrows in that little picture, you have to toss in a negative. So ji is -k, and kj is -I, and ik is -j. So, to do some examples, suppose I have 3i plus 2k, and I want to multiply that times 5j minus k. Maybe that's a little hard for a first example. Let's start off with this first. See how we do. Okay, so you guys know the distributive laws for the real numbers, and well, hopefully you know the distributive laws for the real numbers, right? A plus b times c is ac plus bc. So what we get here is I get 15ij, because we can pull constants out. You can always pull the numbers to the left, just like this was the algebra that you guys are familiar with. And let's see what I have here. Well, I have I times j, that's going to be k. And then I have k times j, which is actually not going to be I, it's going to be -I, because I'm going the wrong direction. So this is 10 times -I, or I could write this as -10i plus 15k. We tend to write the i's towards the left, the j's towards the middle, the k's towards the right. If there's a pure real number involved too, we put that in the beginning of everything. For example, if I have 2 plus 3j times, let's not make this one too hard yet either. Let's do times 7j. Okay, well I get 2 times 7j, so that's going to be 14j plus, okay, this is going to now be 3 times 7, which is 21j squared. And we know that j squared is -1, so this is 14j minus 21, or 21 times -1, but we tend to write the pure real part, the part that doesn't involve an ij or a k, over on the left. Now if you guys are going to add quaternions, let's say we wanted to do 2 plus 3j plus 7j plus k. Let's just add a k in there. Well, you just add the different points. I only have one pure real part, that's 2, and I have a 3 plus 7 for j, and I just have 1k. And that's how we can add quaternions. For another example, let's say I have 1 plus 5i plus 2j plus k, and I want to add this to 2 plus 3j minus k. Well, I just get 1 plus, there's no I over here, so 5i, and then I get plus 5j, and now I have plus k minus k, so those are going to cancel out, and that's what I get. And the i's to the left of the j, so that's a nice form for us to leave it in. Let's just do one more example where we multiply some quaternions. Let's do 2i plus 3k times j plus 2k. Okay, so let's try this out. Now, you guys are used to multiplying two binomials, hopefully, right? You could use FOIL, but you could actually do them in any order. We do have to be a little careful about the order, but we only have to be careful about the order when we multiply the individual pieces. For example, when I'm doing my first, let's say I do my 2i times j, I get 2ij. I have to be very careful to write 2ij and not 2ji, because that'll give me a different answer, because this is not commutative. And then get plus, this is going to be 2i times 2k. And then I could have written 4ik, that would have been even nicer. Then I'm going to get plus 3kj, and then finally plus 6k squared. I could have written 3k, 2k, or 6k squared, because I can pull the constants out of the I, j, and k. So, just to write that a little neater, plus 4ik plus 3kj plus 6k squared. Okay, well, ij is k, so that's 2k, and now ik is negative j, so this is going to be 4 times negative j, or negative 4j. And then kj is negative I, so I get minus 3i, and then minus 6, because k squared is negative 1. And I would write this as minus 6 minus 3i minus 4j plus 2k. And that's my final answer.